When I go searching for food, I head to the grocery store down the street or the farmer's market if it's Saturday. Or down the block to the bagel place because bagels are a hugely important food group and I could eat them for every meal. But I don't have to grow the ingredients myself, which is at least in part thanks to floods. Let me back up about 15,000 years and explain. When people started moving from hunting and gathering to agriculture, communities sprang up along rivers. Rivers provided water and even food like fish, but more important was the land alongside the river that holds water when a river floods or overflows its channel, the floodplain. Alongside rivers, agriculture bloomed in areas like the Fertile Crescent, in what we now know as the Middle East and North Africa region. Regular floods along the Nile, Tigris, and Euphrates rivers replenish the soil with nutrients, which makes them perfect for growing some of the first wheat varieties, along with dozens of other foods cultivated for the first time thousands of years ago. Floodplains led to a food surplus, which eventually meant not everyone had to produce food, which is really important for our communities today. But there's also a price for living on a floodplain. We have to contend with seasonal flooding or even catastrophic flooding from dam failures or intense rain during severe storms. So for millennia, humans have tried to strike some sort of balance and understand why floods happen, both in spite of us and because of us. I'm Alize Carrere, and this is Crash Course Geography. Last episode, we explored how a river or a stream, which is a body of water that flows through a channel and uses gravity to move from high elevation to low elevation, shapes a landscape and all the characteristics that make a river a river. Of course, the most essential element of a river is, well, the water. And how much water is in a river is a key ingredient in flooding, which actually depends on where the stream gets its water. Stream levels can change as overland flow changes, which is water that flows over the Earth's surface from precipitation or snowmelt that doesn't infiltrate or absorb into the surrounding soil. But actually, much of the base flow, or the average constant level of the stream, doesn't come over land. Underground, water makes its way through soil until it reaches an aquifer, river, lake, or ocean. So stream levels can change from the groundwater flow, which is the flow of water within the soil when the soil is fully saturated. And we have names for the different types of streams that receive mostly overland or groundwater flow. A seasonal or ephemeral stream will only have water if there's been enough precipitation. But perennial streams usually flow all year and are fed by underground sources. Basically, because of the way groundwater is stored and because it evaporates slower, groundwater flow is more consistent than overland flow, which depends on the sometimes fickle precipitation. But if either of those sources suddenly increases, how much water is in the stream and how fast it's moving can also increase, leading to a flood. In fact, messing with these sources are fundamental ways humans can influence the flow of a stream, either accidentally or intentionally. So we have to be somewhat diligent. To keep track of river levels, particularly after a storm, we can construct a hydrograph, or a chart that shows how much water leaves a stream or discharges over time. With a hydrograph, we can understand how the stream responds to things like average rainfall and snowmelt, or tides and storm surges. And we can see how often those natural processes add a sudden influx of water to the stream, and when that might cause a flood. Take for instance Indonesia, specifically the island of Java. Most of the rivers on Java are seasonal because the island has distinct dry and wet seasons and a tropical monsoon climate. We can see from this climograph, which shows the relationship between two climate elements, that the wettest months are January and February, but rain is common from November to April. It rains more in the mountains where the headwaters are, so even if there isn't a lot of rain at sea level, the people there can still be impacted. The river then has to handle all that water. Just like the geology of the basin helps decide how a river shapes the landscape, it also determines how the stream will react to more water. Like if the basin has a lot of permeable soil, flooding might be minimal. But if the basin is full of less permeable rock like pavement, shale, and sandstone, then the extra water has nowhere to go except the river itself. Because Java is mostly made of volcanic rock, which is good at absorbing water, we might expect there to be a lot of water infiltration, and we'd be mostly right. But while volcanic rock can be quite porous, Java is very mountainous, so there's a steep drop from the headwaters to the river basin that keeps the water zipping along without absorbing into the rock. And the city of Jakarta, the largest city on the island, has a really high population density. This tells us that the area around the city probably has a lot of urbanization. So there are lots of buildings and less vegetation, and a lot of surfaces that are impervious, or can't absorb fluids, which impacts the ability of the area to absorb extra rainwater. And like we saw before, Java has a lot of rainwater. So the climate and geology of the drainage basin, along with human involvement, can set the scene for major flooding. In particular, Jakarta has at least 3 major factors that cause serious flooding almost annually. First, Jakarta is a delta region, which is an area at the mouth of a river where sediments are deposited. The full volume of water from the drainage basin flows through the delta, and in Jakarta's case, not just one river and river channel ends here, but 13 major rivers flow through Jakarta to the Java Sea. Secondly, as sea levels rise, the base levels of all those rivers move inland. Like we talked about last time, that shifts the way the river flows in its channel, and can make it tricky to predict where water will flow in a flood situation. Finally, Jakarta gets most of its drinking water from underground water found in aquifers. As that water is removed, the river water zipping down from the headwaters is moving too fast to absorb into the floodplain and replenish the aquifer at the same rate. So the land goes through subsidence and actually sinks down, filling the areas that used to hold water with the land above. And in the floodplain and delta, intense urbanization with lots of impervious surfaces keeps floodwaters from being absorbed into the surrounding soils. With a monsoon climate, seasonal flooding is nothing new in Java, but now there's less groundwater flow and a lot more overland flow, which upsets how the river usually responds to extra water. River systems naturally move water through a region, but when that flow is altered, the water still has to go somewhere. We call urbanized watersheds like this one flashy because the stream response is often met with quick, intense flooding, which means less time to tell people to evacuate and more damage to property. Altering the floodplain itself can also exacerbate these factors. Like if we modify the river's channel by adding dams, the river's natural course gets disrupted and water can pool in places it doesn't normally, like the lake behind a dam. In larger rivers, especially ones we use to transport a lot of stuff, we'll sometimes try to channelize the river, which is when we cut a straight, deep channel to prevent the river from twisting and turning naturally. But without these meanders, the river can't do its erosional work or absorb into the floodplain, which usually slows down the water. So the velocity increases, and with nowhere else for the stream's energy to go at times when there's a lot of water in the river, the water will overflow the channel. But urbanization isn't the only factor to blame. The agricultural parts of Java also make the watershed more impervious. Historically, Java was covered in rainforests with mangroves on the coast. A well-vegetated landscape like that slows down any precipitation, giving it enough time to be absorbed into the soil, which is key to recharging groundwater stores, like aquifers. But when the vegetation is removed, precipitation can hit the ground fast enough to keep moving until it meets a river rather than infiltrating the soil. It can be particularly devastating when we modify wetlands, which are the parts of the floodplain or delta covered in standing water for at least some of the year. Because, and I'm not exaggerating here, wetlands will save us all. Wetlands are like the kidneys of the earth. They tend to have soils that absorb a lot of water, which slows down the flow, so they naturally filter out impurities and pollutants, like our kidneys do in our bodies. Wetlands are so amazing at storing and filtering water that we sometimes build artificial wetlands to help control flooding or to filter pollution. Like in mining areas, it's common to see yellow or orange water, which is not a good sign. This water is acid mine drainage, which is acidic water full of heavy metals like manganese, iron, and aluminum that can pollute the entire watershed. But wetlands are such powerful filters that when acid mine drainage flows through a wetland, the water that comes out tends to be less acidic, or even neutral. The suspended metals are naturally filtered out, and we can collect and remove them. So we've actually constructed wetlands at the mouths of mines specifically to clean the polluted water coming out. Though while constructed wetlands can do amazing things towards cleaning up pollution, there are debates about how ethical it is. Wetlands, like floodplains, are ideal building and farming sites. Once drained, wetlands have nutrient-rich soils, are usually flat, and are near freshwater supplies. So sometimes developers will swap a wetland, destroying one and building another somewhere else. But wetlands aren't interchangeable, and the role of a wetland in a particular stream system often can't be replicated. Getting rid of wetlands means that there's no longer a natural sponge in the stream system that absorbs and slowly releases excess runoff. With nowhere for water to go, it will move really fast through the floodplain and into the next body of water, causing, you guessed it, frequent flashy flooding. These spaces have particular flora and fauna too, and those don't necessarily move with the reconstructed wetland. As wetlands are paved over, entire ecosystems are lost. So there's a continuous battle between how rivers want to shape the landscape and how we want the landscape to be shaped. Rivers have supported us since before we founded our earliest communities, but we're still learning how to coexist. We still start massive watershed construction projects, like channelizing rivers or even moving the whole direction in which rivers flow. And while those modifications might help human settlements for a time, rivers and wetlands tend to revert back to their original function with each major flood. And those floods get worse the more modified the watershed is. Humans try to bridge this gap by constructing new wetlands or replanting mangroves. As we learn more about the benefits of floodplains and wetlands, we're finding more ways to work with nature instead of against it. So consider getting to know your watershed. Understand how it drains and where additional vegetation might help break up a flashy tendency. We all live in a watershed, and understanding how yours works might be a great way to get your boots muddy with some local geography. Many maps and borders represent modern geopolitical divisions that have often been decided without the consultation, permission, or recognition of the land's original inhabitants. Many geographical place names also don't reflect the indigenous or aboriginal people's languages. So we at Crash Course want to acknowledge these people's traditional and ongoing relationship with that land and all the physical and human geographical elements of it. We encourage you to learn about the history of the place you call home through resources like nativeland.ca and by engaging with your local indigenous and aboriginal nations through the websites and resources they provide.